from Argentina, and I moved to Berlin 4 or 5 years ago. And in the process of learning German, which I'm still, I learned many ways to greet people in the morning. One is this one that took my attention. This na. What does it mean? It's both hello and how are you doing in just one word. And the funny thing that also serves as a reply itself. So you say nah, the other say nah, and it's a complete conversation where both parties say hello and ask how life is going. So if you're someone like me who hates to speak in the morning, this is the best solution while you are here staying in Berlin. So first I would like to say Anna. I don't know where she is. Well, because this is the first time we present the LetterSpacer in the conference. I will share with you some of the basic ideas behind this automatic spacing. So how this project started. When I think about the topic of this TYPO Labs edition and the question about how far can we go, literally, I can tell you that this project started almost 12,000 kilometers away from this point where we are today, at the Faculty of the Architecture and Design at the Public University of Buenos Aires. During our time studying at the Type Design program in 2009, we began to explore the existing methods and techniques to create consistent spacing in Latin fonts, as well as doing our first steps creating scripting tools for font development. The first tools we created were an attempt to extend the Walter Tracy's method for side bearings relation and work as possible and scalable alternative to metric classes, to be applied in our initial designs and academic exercises. Instead of repeating metric schemes that need to be tweaked and reprogrammed for new designs, we explored the idea of storing the relation between side bearing in a script. But the scope of this alternative proved insufficient anyway, because there are too many letter forms that cannot be standardized, and spacing is not about the absolute value of the side bearings. With more experience and knowledge about Python language, we decided to start doing different scripts to do measurements and tests over fonts. We focused on area calculations over black and white space and how to compensate them. So this our first discoveries. We started calculating the area between super basic shapes, like a square, a circle, and triangle at the same height. This area is defined by the space between the shape and the side bearing, and it's a result of the multiplication of the height by the side bearing. And this area creates the spacing rhythms. When this area is applied to other shapes like a circle or like a triangle, results in a very short side bearing because of the amount of the white area in the letter A or like in an open shape like a C or like an L. The absolute space between letters in a good spacing is not equal arithmetically. Because of this, we came up with a second value to compensate these differences, a depth parameter that allows to measure the width, but only at a certain distance from the side of the shape to its center. In this way, we were not measuring the whole side of the shape, but a controlled portion of it that will be the same in each ellipse. We also assumed that the shapes that work as a system when they have a similar height, aligned at the same vertical range, in type design, we know the space rhythms is also related to the height of the shapes. And glyphs are spaced in groups that share a common height. We added one more shape to this experiment to try with the most tricky situations, concave shapes. We add a C, or like typically a T or an L, where the white gets inside the letter form. We also discover that it doesn't work if we measure the whole white inside the shape. And apart from using a depth from its side, we need to close that open contour. We established a general rule to close that shape at 45 degrees. So the mechanism that we found useful was set a vertical range in common for the shapes that we want to space. Set an area value. Set a depth from the sides of the shapes to its center. And close all the angles at 25 degrees. But we found us with a vertical range problem. We started to apply these concepts that I showed you before to glyphs. And we found that the main problem of a consistent spacing through a font is the different nature, origin, and use of the different writing systems that coexist in our type world. This means that we expect different spacing depending on the group of glyphs or symbols. The main case is represented by the basic letters in their uppercase and lowercase versions. Both systems are different in height and construction and require to be considered as different groups. At the same time, the way that they are spaced depends on design decisions based on cultural, technical, or shape-related reasons. If we think of other scripts, like Cyrillic, we have glyphs that share height with the Latin groups. But due to its design, the proportions and inner spaces may require a different spacing, even for letters that are exactly the same shape as Latin. The figures are another typical group that coexists with letters and different scripts, but need specific attention and design requirements. So, how does the method work? It's now a script for Glyphs app, but because it is a free software, anyone can port it to any software, platform, or programming language. And now it works with two different basic scripts. One of them works with a user interface that allows to specify parameters to a glyph selections. As we can see here, what you see on the left is the parameters that are by default. But here you can see you select a glyph, here is the letter O, and you apply different, and you make different trials. So the second script applies the same algorithms without the user interface. It will apply the default parameters or the custom parameters set in each master. So in each master, you have to set these three parameters. So I'm going to talk about the three parameters that we have to set. The first one is the param area, the area in 1,000 units. If we measure the area of this rectangle in the font, we will have a value that is the result of the side bearing by the height, but the x height, sorry. This absolute value could be like 500,000 units. To make it easier, we set these parameters in 1,000 units. The other is the param depth. It's the depth from both sides of the glyphs, from the bounded box sides, as a percent of the x height. And the third one is the param over, the extension over and below the vertical range as a percent of the x height. It also creates a text file in the font source folder where standard group values are set. The file must have the same name as the font source and must be stored in the same folder where you have your font file. Each desired group will be declared in this text file. The basic ones are created by the program with standard values. In each group, it is possible to set up a script, category, subcategory, coefficient, reference clips, filter by name. These categories or subcategories can be found at the list view in Glyphs app. So we are going to see two examples of this. The first one, so this means Latin script. This is the script that it's appeared, as I said before, in Glyphs app category. And it could be Cyrillic, Devanagari, Arabic, or an asterisk. That means any script. The category in this case is letter, but it could be figure, symbol, punctuation, etc., or an asterisk that means any category. This subcategory in this case is lowercase, but it could be uppercase, small caps, etc., or an asterisk meaning any category. This is the coefficient 1, means there is no alteration of the area parameter. This is the reference letter that will be used to establish the vertical range for this group or classification. And this is the filter. The glyphs in this group will be filtered if they contain this string in their names. In this case, asterisk means no filtering. So we are going to see the second example. As I said before, here means all scripts, the asterisk. This is letter category, uppercase subcategory. Because of this group is uppercase, it's for uppercase, we want to increase the area that we set for the lowercase. In this case, multiplied by 1.25. That means 25% more. The coefficient of 1, as I said before, 1.25 adds 25% to the area in the uppercase group. Using the uppercase 8 for the vertical range, this means that all the glyphs in this group will be measured from the lowest point of 8 to its highest point. And the last parameters will filter all the group to those glyphs that have the string alt in their names. The way to configure parameters and config file, it is just an example. But the method is open enough to allow any designer to try different design approaches. For example, use a different glyphs group for the basic spacing, like uppercase, and reduce it proportionally for lowercase. Use other glyphs as vertical range, like a lowercase for uppercase, and the space will be measured at x height. When we measure this area for the lowercase as our reference, it will be scaled for other groups with different height. Other uses is like use special glyphs for the vertical range in scripts like Devanagari, where the range but not include the top stroke. In this method, we do not use the vertical metric in the font. In order to measure that area at a specific height, we use the reference glyphs as we explained before. Then we tried to use this method to space Deva font, and we found that the best solution was creating these extra glyphs that you can read there, called Deva height, that covers the vertical range that we need. So for this Devanagari group, we use this additional glyphs called Deva height, and this glyph is just shorter to not reach the top stroke and measure the area that is below. And create special groups based on name, like ord, for a group with ordinals, could be ord feminine or ord masculine. Other useful functions, like tabular spacing, allows to establish the same advanced width to a selection of glyphs and center the glyphs according to the parameters. This is useful for tabular numbers and monospaced fonts. The script can be hard-coded setting tabular version to true to never change the advanced width. These settings will never change the advanced width of characters. With this setup, the script will center the shape optically in the glyph's width. The UI allows to select a specific site that wants to be changed. This can be useful for cases where the glyphs are connected on one site, and the space is manually controlled like the Banagari half forms. Here, I'm going to show you a little demo. I broke the spacing of this font. Like here you start with a lowercase and an I, and you change, like you try different areas. I cannot see from here. So, well, and then you add other shapes like O, or you add like R or V with open contours. And then you select the whole group of glyphs and you apply. Then it's too much. And then what you need to add is the depth. So here we add the depth. And here you can see how it changed. And then to show you how works the overshoot, you need like letters with ascenders or descenders. So here I was trying. I add these demos yesterday to my presentation. And yes, and this is how you can try while you are designing until you have a result that you like. Here I want to show, like, once you were trying different parameters, then you can add these parameters to the font info. So you don't have to remember all the time using the UI. So you have to set the 3 parameters, the area, the depth, and the third one, the param over. And you store these in the masters. And you can use the same values every time. So here I will show you, I run like the script using the parameters that are stored in the masters, and you can see. And I am doing the same. I think so. No, it's the next one. Yes, sorry. Yeah, here, sorry. Because before I did that with the sans serif, I decided to do this with Alegreja. This is from Juan Pablo. The parameters are already stored in the masters. So you run the script, and you can see how it changed in the black and now in the regular. I'm doing the same. You can take a preview here. And what I want to show you here, I forgot to do that in small caps, so I ran the script again. And what happens if you already have these parameters defined, if you change this config file. So for instance, if you change the proportions for the uppercase, what you are seeing first is the default numbers, but you can change that. So if you want to keep the spacing that you already decide, but then you decide like your uppercase will have like a more open spacing, then you directly change the config file. So of course, for this script, there are some limitations. One of them is like the method is not possible to space connected shapes. And the other is that the method assumes that the proportions of the glyphs are similar, but sometimes the design is made with different proportions, typically uppercase with classic proportions. So if the inner space of the glyphs is not constant, why the spacing should be. But in cases like this, the designer can be creative and create different glyphs groups based on proportions. The punctuation needs another special attention and usually requires specific design decisions. The software can help to set tabular punctuation in the best way. We want to say something like some people may consider this software as the solution to all spacing problems, but maybe others may be skeptic. We think that things are not black or white. The software can be used to space the whole font or solve specific spacing problems. It's definitely very useful to create compatible spacing for proportional and tabular figures. Space small letters and figures like superiors very quickly with a great accuracy. Space symbols with similar shapes very quickly. And create consistent side bearings for similar shapes. And what is very useful is to create a spacing test. Like if a client asks you to, because wants to see your font with more closed or open space, you can make different trials and send these trials to your clients super quickly. Reduce the time spent on sketches considerable. As soon as you draw a letter, well or bad drawn, you can space it very quickly. Use fixed spacing values in co-working. So when different designers are working in different blocks of the font, because of the thing like you store in the masters, the parameters, it's much easier if other people are working with the same project. So we have an invitation for you. The software, as I said before, it's free. You can do almost anything you want with it if it remains free. We invite you to test it, to adapt it, and to modify it. We invite you to use it in creative ways to propose new ideas to improve it. You can see our Git project repository in this address. Also, you can collaborate with the project, reporting issues, creating your own branches or forks, and requesting updates to the software. And you can give some feedback or follow the discussions on Twitter. And we would like to say thank you.